What's up everybody, welcome to my new video. Today here we have send temperature values to the computer. I believe I already did that. We have this right here, serial prints. So I put the code in there. The text that appears in the serial monitor will look like that. Alright, convert sensor reading to voltage. Okay. Convert the sensor input to a volt scale. Sensor value divided by 4 times 5. Okay. Voltage. Alright. With the little math, it's possible to figure out what the real voltage of the pin is, and the voltage will be a value between 0 and 5. And it will have a fractional part. For example, it might be 2.5 volts, so you'll need to store it inside a float. So it's just going to be a float. That's why I was wondering why it was a 5.0, but it's going to be a float. So you need float numbers, even though it's a full, a full 5. Create a variable named voltage to hold this number. We'll simply rescale the number to a voltage. Divide that number by 10.24 and then multiply by 5, like we've seen here, and then it'll be printed out to the monitor. Yeah, man, it's kind of weird how Tinkercad doesn't let us adjust this. I wonder if you can download Tinkercad for like an actual, like a desktop app. Maybe then. Okay, so now we got this here. This little. Convert the ADC reading to voltage. Okay, so it's gonna be a flow. Is that gonna be under or? I'm assuming it's gonna be under, so we'll put it right here. So we'll do floats, voltage. It's a whole separate reading here. See if I remember it correctly. Oh no, it's right there. It's right here. Let's see. I automatically assumed that I scrolled way past it for whatever reason. So we have a volt, a float of 1024. So that's divided, and then we multiply by 5. Then we're gonna print out serial prints. I wonder if it's automatically looping or if it only does it when there's a change. I would prefer it only if it's a change. That way it could save some memory. Okay, let's see. So volts. So this is kind of like, it's a little bit like console log. Serial print voltage. I completely forgot to add this right here. I wonder if I could edit this outside of this Arduino. Or can I run it outside of this? Can I download like a MP package? NPM. Or somehow, Does it have to be here? Okay, including the data collected in the previous step, the information in the serial monitor will look like this. So voltage, cool, serial prints, all both included. Oh, there's no break. You have to add that manually, end of line or something like that. Alright, let's do a few more steps. Convert voltage to temperature. I like this step at a time. Little by little. The only thing is that it's a lot of reading. Well, not too much, but it's some reading for a video. It's some reading. So now we're gonna take the voltage and we're gonna subtract it by 0.5, then we're going to multiply it 100, you will get the accurate temperature in degrees Celsius. Really? To convert voltage. Voltage is in temperature? Subtract 0.5. So 5 volts. 4.5 multiplied by 100. 450. 4.5 volts is 450 Celsius. Is that... Wait, is that true or not? Store this new number in the floating point. Okay, we won't look at that. We'll just go directly to this. Convert the voltage to the temperature in degrees. Okay. And I'm assuming we're going to print it out as well. Temperature. Voltage. Minus, what is it? 0.5. Times 100. Do I have to do float or no? I think I need to do float, so it would have to be like that. I don't have to. Just do that then. Then why did I do it for this one? If I didn't have to. It's weird, huh? Okay, so now we do, again, we're gonna do, oh, this one's a little bit different though. Wait, hold on. No, this one was just print. Print LN. Does that mean that's the end of the line? I think that's what it means. So, serial. Print. And then, comma degrees. What's it gonna be? Degrees, like that. Let me just guess. Like that. Serial. Parallel. Oh no. Temperature. There it is. Okay. Is that how it is? Degrees. Oh, degrees Celsius. Pretty much. Temperature. That's all that is. Including the previous two steps, the serial output will look like this. So we have value, volts, and degrees Celsius. So 150, no, so 0.75 volts is 24 Celsius, 24.7 Celsius. 24.7 Celsius is, I don't know how many degrees Fahrenheit. I live in America, so we use Fahrenheit, unfortunately. That's what I'm used to. Okay, so since the temperature is the last thing you're going to be printing out in this loop, you're going to use a slightly different command. Print line. This will create a new line, serial monitor after it sends the value, making the data easier to read. Alright, cool. Next, turn off LEDs for a low temperature. I think we're still here. Because it's just depending on the temperature, we're going to keep looping and then changing the temperature. Now, I don't know if this is going to work because this works here. It works here. But I don't have this. I have a humidity / temperature sensor. It's still 3 pins. So it may or may not work. Who knows? Maybe it has different inputs. I don't know. I'm still, right now it's wired this way. So hopefully it works. For every 2 degrees of temperature increase, I'm gonna turn on an LED. Start by turning all of the LEDs off. I thought I already had it. They were already off. Baseline temperature. Oh, right here. Oh, so I could change the baseline temperature. If it's below the, oh, I see. Okay. Always constantly checking if. Yeah, if else. We're gonna do something else. Okay, cool. Temperature. Base. Baseline temperature. Digital right. Whatever number, and then it's gonna be low. So what I'm gonna do here is I'm just gonna go ahead and copy everything here. Paste it like that. Digital right. 2, 3, 4. That's it. As far as the if else statement goes. Recall that the baseline temperature is currently set to 20 degrees Celsius. You can change this later if needed. Yeah, I don't know how much. I don't know what that is. That's in Celsius, right? Continue to the next step. I'm gonna end it right here. Thank you guys for watching. Y'all have a good ass day. Peace out.